Hey, you guys. Jim Vinosky with Manufacturing Talks. It was a little over 2 years ago, I wrote about this concept I'd heard about for the ultimate mobility vehicle. It was being explored by this little arm of Hyundai Motor Company called New Horizon Studios. And then last year in the fall, I got contacted by some folks in Montana saying, you need to come out here and check it out because they're actually putting in an R&D center out here. So went out there, checked it out, and yeah, they're getting close to being where they're going to be building these crazy legged wheeled vehicles that can go anywhere. So tonight we've got a member of the New Horizon team here, and he is going to fill us in on where they stand and why they landed in Montana and all the cool stuff going on with the ultimate mobility vehicle. So stay tuned here on Manufacturing Talks. We'll learn all about it.
Welcome to Manufacturing Talks with Jim Vinosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
EYS Media, your digital media relations agency. Public relations, website design, digital marketing. You get found by the customers and talent who need your solutions. You get media placements in top publications, the best job candidates coming to your website, a digital presence that gets you found by the right people. Call 616-298-8798 to get started today.
Hey, everybody. Welcome back to Manufacturing Talks. I'm Jim Vinosky, your host. And thanks to our sponsor, DYS Media. You just saw the clip from them. Awesome outfit. You got to look them up a little further. And just really, really happy to be here today with Jake Bernal. He is with Hyundai's New Horizon Studios and Montana State University. Welcome, Jake.
Thanks, Jim, for having me. It's really great to be on the show.
And it's great to have you here. It's been a while making this happen. You're a busy guy, so really glad to have you on. Before we get going, definitely want to hear about your background, what you got or what got you where you are today, what tied you in with the big venture out there with what we'll talk about, the ultimate mobility vehicle.
Yeah, no, my story is not too different from a lot of mechanical engineers. That's what, my degree is, my education is in. I got that degree through Montana State University, and I'm still in Montana. So, there's industry that kept me here, and that mechanical engineering degree led to a couple of different opportunities. I did a little bit of engineering with the Army. I was full-time Army for a little bit. And then I was asked to actually come back to the university to teach their manufacturing processes and CNC work. So while I am a mechanical engineer, I've done a lot of manufacturing engineering as well. I taught CNC manufacturing processes at the university, as well as did a lot of research advising on a wide variety of projects, whether that's biology growth in space, satellite technologies, drone work, which, as we know, drone manufacturing is getting really big kind of throughout the country with Part 107.
Yep.
Did a lot of those small projects, those research, and the opportunity came up for me to transition from academia back to industry, which is nice. It's a good balance to have as a mechanical engineer or any engineer in general. Balance your academia and your industry time. New Horizon Studios, a wing of Hyundai America Technical Center, and we're doing research and development on behalf of Hyundai, specifically for the ultimate mobility vehicle, which is a lot of people want to think of it as a branch of robotics. There are robotic elements of it, but it is a vehicle. It comes in a couple of different variants. There's vehicles that carry people, obviously, but there's also vehicles that move equipment and stuff like that. And there's a lot of use cases for the technology that we're developing. But that's how I ended up getting to New Horizon Studio. And, it's been really interesting that journey there, going from education, getting a little bit of experience, and then teaching for a couple of years. A lot of engineers will be tempted to go straight into industry and stay there, but it is important to hone those skills of how to teach others, because what I've noticed is some of my peers in other companies that went straight into industry sometimes can forget how to teach and mentor when they get into middle management. So for the young engineers out there, it's important to remember that your middle managers, they've been where you're at, and to take use of their experiences.
Right. Yeah. So I recorded a promo or an intro to the show before we got on, and I mentioned the background, how I'd written about the concept of the ultimate mobility vehicle a couple of years back. And, I'll have, for those of you watching the web show, you'll see the graphic of it. If not, definitely go look up New Horizon Studio and the ultimate mobility vehicle and see what it looks like, because it's really, really cool. And I'm just curious. I mean, the concept, you see other things like this, but I've never seen this particular take on it. And then some of the use cases you mentioned are brand new to me, being kind of outsider looking in. Can you tell us more about where that concept came from and some of the technologies involved that you guys have worked out?
Yeah. So the ultimate mobility vehicle is really, there's a couple of concepts out there, like you said, that already exist. They're not necessarily competitive cases, but it's really pushing the boundaries of what you can do for mobility case in automated systems, right? So there's always been challenges, even going back to the 80s, for automated navigation and vehicles like that. And people have figured out how to take vehicles across the desert in a automated way, and such that the vehicle has its own perception systems and navigates on its own. The next layer of that is traversing terrain or situations that vehicles currently built cannot, and integrating that perception that we've developed over the past 30 years, both vision systems, LiDAR, radar, incorporating all of these technologies in a vehicle that can actually see as well as navigate on its own. The ultimate mobility vehicle takes into account the thing that humans and regular animals can do, and walk, really. Right. Yep. A car can't naturally walk. A Jeep can't walk. A motorcycle can't walk, but there are always terrains that require that type of movement. So how do we take a natural take, a take from nature, and incorporate it into a vehicle that can drive just like a car, incorporate those benefits? And we've seen it in literature and popular media, robots, machines, carrying devices that look in similar shape, have leg architectures that are similar in some ways. The hard part is getting it off of the print page or the digital landscape and converting it to reality. So when Hyundai started looking at, can this be done? While they did see other technologies out there, a lot of people reference Boston Dynamics of robotic systems that can perceive enough of their environment to do a specific task. The UMV has the architecture, the physical architecture to do walking and driving. That's in one way an easy part. It's not hard to, conceptualize. It's hard to design it, but the real challenge with the UMV is integrating it with perception and control technologies. So that's where Hyundai is taking a little bit of a different path to achieving the UMV. So we've taken systems like Boston Dynamics that we know the hardware can be done, and we have taken perception systems built over 30 years or 40 years of experimentation by dozens of companies and integrated those together. It was only in 2019 where it became mechanically feasible to dedicate, a role to building the UMV. And the UMV has two variants that we're pursuing, a person carrying one. Right now, we started with a middle of the road approach option with carrying like two people in a varying use cases. Right, we could carry two people in a lot of different ways. We could have one that's made for highway work and one that's made for like super Rubicon type stuff. We can make one that's amphibious. We could make one that's for lunar purposes. But we chose to pursue the roboticized suspension portion first. And then we also have a smaller variant that focuses on either hard to reach locations that don't necessarily need to carry people. So cargo carrying variants, sensor platforms, those are the two sizes that we're working on. And it's been a really interesting challenge. You know, we've got some metallurgy work that is going into how do you add a suspension system in, or some flexibility in an easy to manufacture method that protects, you know, our motors, our actuators, our transmissions, all of those components while maintaining that enhanced flexibility. What special characteristics are we taking into account for cabling systems and wiring, for fatigue and that kind of thing? I mean, copper wiring doesn't like to be bent the same way over and over and over again. So those are all things that we're taking into account on this. And these aren't issues that are new. These are issues that have been seen in multiple industries, and we're conglomerating a lot of information from a lot of different sources to make something that doesn't really exist on the scale that we're producing it.
And you're doing things, you know, that are, given your background of studying and developing and you know, coming up with the real world applications of how this is going to work is real to you, but most people are never going to think about those factors, right? That you've got legs, and so things are bending, and if it's copper, it's going to break. So there's a lot of just really mechanical aspects to tackle up front before you ever get into the whole control side of it, right?
It is and it isn't. So when we initially designed the UMV, or sorry, just before my time, it was very mechanically focused, taking care of a lot of these considerations. And what we ran into was we were, you know, putting the cart before the horse a little bit in some ways. And that it was recognized early on, and we adjusted course, but we had to integrate electrical engineers and control engineers. Sometimes when people think of new mechanical technologies, especially robotics, they overlook all of the supporting disciplines. Right. Technology. And depending on what you make, like if you're building a computer, people think electrical and computer scientists. They don't necessarily think about a mechanical engineer that needs to build the heat sinks for the, you know, all of the chips inside. When we're building robots, people forget about electrical and computing. The UMV, you know, after our initial design, really incorporated that. So now every component we design goes through a design review, just like it should with any professional manufacturing. A design review with all the interested parties. You know, how are we routing cables? How are we minimizing kinking? How are we ensuring that we don't have electromagnetic interference in all these systems?
There's got to be a piece too. You know, I know a lot of us kind of in the techie world got introduced to the notion of something being beyond the human ability to operate with the stealth bomber, right? It actually takes a computer to function, which for something like that, no one's surprised. But I have to believe that even with something like this, which is, you look at it in its basic configuration, it looks just like a regular vehicle till you realize, the wheels become legs and it can walk. There has to be something to that walking element that's also very technologically challenging.
Yeah, and there's quite a variety of methods you can use to stabilize a system like this that has leg architecture like that. And we're pursuing all of them, right? Because if we look at one and we go down that rabbit hole really, really far and we realize it's not feasible, it's either wasted time or wasted effort, right? So we're pursuing quite a few options right now because we are exiting, our phase one of development. We've got prototypes now. Our software is constantly being refined as we update the hardware to achieve the capabilities we want. So there's things like motor feedback, right? So each motor can output to us torque values. And we can read those torque values and say, oh, well, this leg is being stressed in this way. It's probably like hitting a rock or something. Mm-hmm. You could take that feedback, put it into a computer, have it analyzed, and have the legs articulate in such a way to keep the vehicle stable or achieve a status. Yeah. There are downsides to that, right? Yeah. And that is speed of feedback and how fast can the computer compute. Another way is having strain and force sensors on every component. Again, it's the same thing, but processing power can be an issue there. And then there's vision perception, which can anticipate those impacts or the terrain in some way. Perception with vision has been used for a really, really long time because it's very reliable. The issue being graphical processing power. Nowadays, with how dense we can get a chip, processing power isn't our limiting factor anymore. Right. There are computers, depending on the variant, on UMVs that intake this data, process it, and articulate those legs. So like you said, the human brain, and with only two hands, we can only have so many controls on the UMV.
Right.
You're forward, back.
It, right.
Yeah, like I don't have four hands to control each leg. So the computer has to pick up the slack of what my physical biology can't put into a controller or a touch screen or something of that. And the UMV has incorporated a variety of those feedbacks in order to get to where it is. It is a multifaceted issue.
Completely a geek's dream for sure, right?
It definitely is.
So I wrote about this a little over 2 years ago, and then I get a call last fall. Hey, you got to come out to Montana and check out what your buddies at Hyundai are up to, because they're actually moving on this thing, right? And found out that it was like 6 months before that, you guys had established the R&D center there on the innovation campus at Montana State. So what was it that got you to that point where now you're ready to move beyond that concept that I wrote about initially?
Yeah. So as we built prototypes, it became apparent that we needed a space to test. And in the Bay Area, there are places to test, but there are millions of eyes on this technology as part of it. But also our use cases are super tailored to whoever the potential customer is. We have potential customers all over the world with different use cases, but having a location with a variety of use cases local was going to be helpful. Montana offered a lot of use cases that were outdoors. So we figured, well, let's get somewhere that has a lot of outdoor space for us to test with, a supportive state. And that presented itself as an opportunity itself is in Montana, we have a lot of outdoor research that already happens based at universities. And Montana State University had the opportunity of the innovation campus. So kind of the perfect storm of opportunity, not only for the technology to be able to develop faster, but also to bring jobs into the state and have an opportunity for graduates of the university, as well as people that are still studying, right? We have a lot of interns that come through to be able to put their hands on technology that is up and coming, not technology that was designed 10 years ago and being refined, not technology that is 20 years out, but technology that's happening right now. It brings a lot of valuable experience with engineers coming into the state that have a wide variety of industry experience that we don't have in the state. So it was really beneficial for the state, the university, and us to come in. And the university was extremely supportive. They have the innovation campus, as you know, partnered with MSU or owned by MSU. They're building out technology here, and they're focusing it right next to campus in the center of town. And we were one of the early adopters of this principle of bringing technology to the talent, letting the talent naturally diffuse into the industry pool. And that's really what the Innovation Campus does. You take technology companies and up and coming technology, put it close to the talent, and then let the talent filter itself and naturally join industry that is, best for the student and best for the company because they're getting fresh ideas.
Yeah, well, and it becomes a virtuous circle too, right? I mean, obviously, Montana State and the Innovation Campus there had strong offerings that kind of lured Hyundai and New Horizon Studios in. Doesn't hurt that you got some really rugged terrain to test an ultimate mobility vehicle. But then as you establish a company like you guys on that campus, now there's that bigger draw for top talent to come into the university, and it just kind of builds on itself, right?
Absolutely. Yeah. Montana State's always kind of been a destination for career talent, people that have a lot of career experience, but they want to go back into academia, coming out of industry, after a whole career, 20 plus years.
Yeah.
Some people want to go back into academia. Some people start in academia.
Right.
And a lot of those people say, well, it's a destination location. There's technology there. There's a ton of engineers. There's a lot of opportunity for collaboration with industry. And we do have a lot of talent that comes in to the university system, but we don't have any ability as a state really to retain a lot of that talent if they try to go back to industry. And that's what the Innovation Campus is doing. It's giving a pathway for those who are highly educated, have a lot of industry experience to stay in the state.
Right.
So there's definitely a lot of parties that are benefiting from not just us, but large companies like FLIR that are here, Miltech, Quantel Laser, moving into the state. Boeing is in Helena. There are a lot of companies out here that are coming in to the state because of the amount of talent that's here.
Well, and Montana is doing some phenomenal stuff in the public policy realm, in the collaboration between the public sphere and academia. That's one thing that really impressed me is you've got a great approach as a state to make it attractive to manufacturers to come in. So I have to think that virtuous circle just expands given that reality.
Yeah, absolutely. I mean, people forget how far north we are sometimes. In the continental US, people don't think of it as very far north, but Montana is kind of out of the way for a lot of people when they think about the US. When you ask people to identify states, a lot of people will forget this state unless they've watched Yellowstone, then they know exactly where it is.
Because they're on the map now.
We're on the map now. But that being said, there are challenges to being up here. Obviously, like supply, it's not as easy to get some materials or equipment up here, but there are a lot of talent, hands-on people with experience here, and the state policy has been great. The state government has done a lot to encourage businesses to come in, bring jobs with them, as well as build up the state economy. I mean, people forget about how small Montana is. Like, I work for Hyundai. They made 102 billion last year. The state of Montana made 49 billion.
Right.
So like the whole state made less. And
it's not a small state.
No, it's not small. Like if you compare the size of Montana to South Korea, you start to realize the comparison, but it's just the industrial workforce that is actually already here is the state's very supportive. It's very nice.
Yeah. Well, and you've got a great track record, not just in industry, but the kind of stereotypical background of Montana is people who do things, right? It's not think tanks and government agencies. It's ranchers and people who are out making real things happen. So I think that's a draw as well. So you had mentioned you guys have gone down the road now of building prototypes, developing your technology, and really getting this thing beyond the paper realm. So is it too early to ask when we might see a full-size version of the ultimate mobility vehicle?
Yeah, well, I mean, full size comes in two variants, right? The cargo one, and then
Sure.
the people carrying variant. So
Yep.
I'll start with the big one, right? The people carrying variant. Everybody likes to think of that, although all of the artwork that you've seen and renders that
Mhm.
we started with years ago, those are all of the smaller variants. Some of the new
Okay.
artwork that's going to be coming out this year, we already have it. It's going to get published. There's some. Hyundai actually published an article with a lot of our artwork and technology in it, showing the full size people carrying variant. So the people
Right.
carrying variant has parties that are not just New Horizons Studio working on it. We're focused on the roboticized suspension and control portion of that. There
Mhm.
are other companies that are like a, you know, interior design people, external design people, wiring harnesses for chassis and stuff like
Mhm.
that on a full size vehicle. That is coming together over the next couple of years, 2, 3 years, depending upon the market's appetite for this technology.
Mhm.
The smaller variant is the one that you're actually going to see to market first, and that
Okay.
is because we did that design entirely in house. We do have a prototype. It's full scale. It's all
Oh,
integrated, except that its guts are on the outside. All the electronics and computing right now, we have it set up for quick to hardware development.
yep.
We're working
Yep.
on our
So you
Mark
guys
II
can tweak it
version.
easier.
Yeah, we're working on our Mark II version right now, which is to be completed by the end of the year. And
Nice.
early 24, we're going to have a showcase where everyone will be able to get to see this thing in the real world, going over terrain that is challenging. Um, and that should be first quarter of 24 when people start to see that. That's going to be as close as you're going to get to the production version before production.
Okay. Sounds like I got a plan to come out to see that and to bring my mountain bike along.
Most def. Well, I'm not sure if you'll be able to mountain bike where we're going, but I'll
Oh
keep that a
boy.
secret until
That is some
until you
challenging
see it.
terrain.
Yeah, it is in a it is in a very unique location where we're going to be demonstrating this. It's a very historical location. And there's a lot of history there as well as challenging terrain, which will really show the capabilities of the technology over a comparative vehicle that we see on the road today.
Yep. Very cool. So let's talk a little bit before we finish up about actual real world applications. So are there near term applications that you guys are focusing on where you might actually get these things built for a commercial purpose?
Yeah, so there's quite a few parties that want them for different reasons. And the way we built this from the beginning is that we knew we would have to build modularly, because people are going to need in different sizes, different functions. So that the small function or the smaller variant, we call it mini UMB and micro UMB. Micro UMB is the small one. That one has a lot of Forest Service applications and wildland management.
Yep.
So
they could use them up in Canada right now, right?
Yep. So fire applications could be sensor platforms.
Yep.
They could be cargo carrying equipment for fire crews, hotshot crews.
Yep.
I did fought forest fires here in Montana, and it's no joke. I
don't think I knew that. Did you know my dad spent his whole career with the U.S. Forest Service?
I did not.
That he was.
It must have not come up.
He spent a lot of time out west fighting fires. Yeah. So
yeah,
you guys have that in common. Very cool.
Yeah, we do. It's not a joke. Carrying all of your equipment for miles, digging a lot of fire lines. You run out of stuff sometimes, trying to dig fire lines and you're out of water. The UMV has the ability to traverse land that fire crews are typically having to go on foot because they can't get a UTV like a Gator up there or anything to support them.
One thing that pops to mind as you talk about that is my dad. He really felt deeply the loss of some of the firefighters who got stuck in the bad situations, and I can imagine there could be an application for life saving as well.
Yeah, the UMVs, a lot of the initial concepts you'll see the concept art is all medical search and rescue. And that is because that was the next thing I was going to get into is we got wildland fire. We've got rangeland management. So if you're moving cattle around, checking fences, that kind of thing. Even in like Yellowstone, where you're surveying animal populations, you can use it for that, where it can get to terrains where they're at. Medical applications, down skiers, right? It can traverse extremely deep snow. It can bring medical equipment to them. It can identify them with sensor platform, disaster response, whether that's flooding or I should say high water, right? It can go through deep water with its leg architecture in a fully extended mode. Building collapses, it could traverse over that. One of the things we think about is there's a lot of pictures for at least people my age or older. My sister-in-law is too young. It's a historical event to her, but like 9/11, that had to all been done by people walking over that to go find people. The UMV could be used in similar circumstances to traverse that terrain faster to hopefully find and rescue people. So there's a whole series of those. And so that's FEMA. That's the National Park Service. Each state has a variety of rangeland management agencies that can all use these that are potentially interested. And everybody brings up like Call of Duty when I tell them what the UMV is. And they're like, oh yeah, is the Army going to use it? I mean, there's potential there for it.
Well,
we didn't design it necessarily targeting specific people, but there's most definitely applications for national defense and that sort of thing. So with the varied potential customers, we've built it modularly, different cargo packages, weights, distances that it can traverse, different leg architectures and scales, as well as different materials, if it's a hot environment or a cold environment, that type of thing. So those are all parameters that will go into the production versions when we are engaging directly with customers, tailoring the product to them.
Cool. Excellent. Okay. I am at the end of my questions. Is there anything we haven't touched on that folks out there ought to know about what you guys have going on at New Horizon Studios?
Yeah. I mean, technology is ever growing, right? So as a technology like the UMV comes out, there are a lot of young engineers out there who have ideas, and you should pursue those because the UMV started as an idea by a young engineer, and it was brought up to the right people through happenstance. It wasn't somebody had a bunch of money and had an idea. It was a guy who had an idea, and it was brought to the right people, and we were able to get that idea to someone like John Suh, the director of New Horizons Studio, who pursued this. Your ideas as young engineers are critical to the development of new technologies that increase manufacturing capabilities, create new products, increase economic capacities in their local states or countries if you're not in the US. So, take the UMV and New Horizons Studio as a motivational idea that you can take and feel free to build upon those ideas that you have as a motivation to younger engineers that are out there. And then if you're looking to get into the field of robotics, take a look at the UMV and say, hey, what other robotic use cases are there that people aren't developing? And feel free to pursue those as well, because what we have a lot of times, I have a lot of students that I've had that they have ideas, but they don't pursue them because they don't know if they exist or if they're a good idea. And so making sure that you engage with people who have these experiences, reach out to people that may be interested, as well as people who have knowledge that can benefit your idea.
Yep. All excellent points, Jake. Well, fantastic. Thank you so much for being here, Jake Bernal with Hyundai's New Horizon Studios and Montana State University. Excellent stuff going on out there. I'll put links into the show notes here so you can go find out more about these guys. Anything in particular, Jake? Any place they should look for information about this stuff?
Yeah, I mean, the easiest way to find out about us is to search Ultimate Mobility Vehicle on
Yep.
Google. You will see multiple sites, people that have consolidated information. Hyundai has put out a lot. So if you go to Hyundai Motor Group's research and development page, you can take a look at it there. You'll see our information. And you can shoot us an email at newhorizonsstudio@hatchie.com if you would like more information.
Wonderful. Thanks again. It was great having you on Manufacturing Talks.
Excellent. Thank you, Jim, for having me.
And thanks to all of you out there, our viewers and listeners. Tune in every Tuesday. We've got new stories. Can't promise they're all going to be as cool as Jake's, but they're going to be cool. So long.
Thanks for tuning in to Manufacturing Talks with Jim Vinosky. Watch for new episodes dropping every Tuesday. Don't forget to like, share, comment, and subscribe.